Hey guys, last section of chapter 6 for us. Be careful that you're looking at which sections we're doing because we're not doing the entire chapter. So this video is for 6.5. We're going to finish up the idea of factoring polynomials. So, example 1, factoring by grouping. It is important to note that the reason why that this is different than other factoring is because there are 4 terms. There's 1 term here, 2, 3, 4. So it's important to know that we only try factoring by grouping when we have 4 terms. We look first for common factors and groups of 2 terms. So you're going to look at these 2 and say, what could I pull out? And you're going to look at these 2 and ask what you could pull out. I can pull out a 3x squared common to the first 2, and that leaves an x minus 6. Now, the next 2 terms, I can pull out a 2. Don't lose your subtraction sign here. Pull out a 2 and you have an x minus 6. These 2 things must always match. Now, you have x minus 6 in both of them. You factor that out. You squeeze these 2 terms together and you have 3x squared minus 2. If we verify the results by finding the product, we just multiply these back out and we get our original equation. So hopefully that makes sense. So we only do factor by grouping if we have 4 terms. Now, there is a common error that happens. Make sure that you don't stop factoring when you get to this stage. You must take the x minus 6 out and squeeze together the 3x squared minus 2. So finish the job when you get started. So we factor the first 2 terms and the last 2 terms, and then we factor out the common binomial, and then we squeeze them together. So let's take a look at this problem. We have 10x cubed minus 6x squared and plus 5x minus 3. If we look at the first 2 terms, we can take out a 2x squared. If we look at the last 2, it doesn't look like we can really take anything out, but there's an invisible 1 there. So we want to make sure that we keep that so that when we take out the 5x minus 3 and we squeeze together the 2 terms, we have an x squared plus 1 term. Now, another way to factor is to factor by trial and error. This is your least favorite but necessary method. We look at this when we have a coefficient in front of the x squared term that is not 1. That means we are going to have the 2 terms look something like 2x times x in our factored form. Now we do the same thing as we've always done. What 2 numbers multiply together to be a negative 25? So as we look at that, we end up being able to make a long list of options. Now we don't know exactly where to plug those. So we could have the positive 1 and the negative 25 here, or they could be reversed. We could have the positive 5 and negative 5 here, or they could be reversed. And we could have a negative 1 and a positive 25 here, and they could be reversed. And when you multiply these out using FOIL, you get all of these trinomials. You notice there is one that matches, so you were successful. So factoring by trial and error means that you want to set up your first 2 terms here. Now 15 could be 5x times 3x, but it could also be 15 times 1. So you're going to have a longer list of possibilities when it comes to that. We also have 8. That could be 8 and 1 and 2 and 4. So this is going to be a long list of trial and error possibilities. So looking at this, we are going to advance to the next slide. And we're going to look at another example. This example is a reminder that we first must always check to see if there's a greatest common factor that we can take out. Once we take out the 2xy squared, we are left with a 3x squared plus 13xy plus 12y squared. We have to ask ourselves if we can factor that further. we know it would be in the form of 3x and x to make the 3x squared, and we know that we are going to have a y here and a y here to make the y squared, but we don't know how 12 will be made. Will it be 12 and 1, 3 and 4, 6 and 2, and that's where we will have to look at the possibilities on the next slide. So we're looking at 12 and 1, 6 and 2, and they're reversing, and 3 and 4, and 3 and 4 and 3. And when we multiply all those out, we find the one in which we're successful. So, instead of using trial and error to factor a trinomial, we can factor by grouping. To factor a trinomial by grouping, you can look at the two integers whose product is a to c and whose sum is b. We've talked about that before. So, I will leave the idea of factoring a trinomial by grouping as a method for you to look at on your own. However, I do want to remind you that we have a strategy that we want to think about. Whenever we are factoring, our brain should first ask us, is there a greatest common factor? Take that out right away. Also, if the coefficient in front of the x squared term is -1, get rid of that. We want the x squared coefficient to be positive. Next, look and see if the terms are 3 or 4. If they're 4, you know you're using grouping for sure. If they're 3, and the coefficient in front of x squared is the invisible 1, then you do what we did last section, which is look for multiples of the last term that multiply together and add together to give you the middle term. If the coefficient of x squared is another number, then use the guess and check method. I hope this helps. Factoring is not fun, but it is something that becomes necessary as part of our quadratic equations in Chapter 7. The factors give us very important information about the x-intercepts. Sorry about that interruption. So make sure that you're understanding factoring because it follows us into Chapter 7. As always, if you have any questions, reach out. I hope you're well and safe and have a great week.